Okay, so today we're just going to talk about Unit 4. So if you remember what Unit 4 was, that was that unit that was all about proofs. Okay, so it was all about proving triangles are congruent and using CP/CTC and things like that. So remember the triangle congruence criteria. These are just ways to prove triangles are congruent. There's 5 ways, remember. They are side, 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 angle, side, angle, side, angle, 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 side, and each up. So you definitely need to like recognize those situations when you see them. This does not include angle side side. That's not a thing. Side side angle, which is the same thing as angle side side. It also does not include angle angle angle. Okay, those are the 3 ones that don't work. The other ones do. Okay. In addition to simply proving triangles are congruent, we talked about using CP/CTC after you've proven triangles are congruent. So this is not a way to prove triangles are congruent, but it's used after you've proven triangles are congruent. As a way to show that you have 2 congruent angles or 2 congruent sides. Okay? So let's do an example of a proof. And that'll give you time to work on this in class so I can help you if you need help. So how about this one? What if I have a picture like this? And suppose we're, let's label these A, B, C, D, E. Suppose we're given that AB is perpendicular to BE, and DE is perpendicular to BD, and we're also given BC is congruent to DC. And we want to prove that AC is congruent to EC. Okay, so this is a fairly typical proof. So remember the strategy, use paper, draw the picture, label everything you know, and formulate a plan. So in this case, we have perpendicular lines right here, kind of like that, the way I drew it, but that's perpendicular, and this is perpendicular here. Okay, and then we also know that BC and DC are congruent. So what method can we use to prove that these 2 triangles are congruent?
Angle, side angle.
Yeah, angle, side angle, right? Even though we only have 1 pair of angles that are explicitly given to us, we actually can prove that these angles are congruent as well because they're vertical angles, right? So we're going to use angle, side angle to prove the triangles are congruent. Then once the triangles are congruent, we'll have AC and EC congruent by CP/CTC. That's the strategy. So I picked this one on purpose because the ones that involve right angles kind of are the most work in terms of like the number of steps that you have to have. So I just want to remind you of that process, just so that it's fresh in your memory. So I'm going to do things in that order. I'm going to prove the right angles are congruent first, then I'm gonna have the two sides, then I'm gonna prove the other pair of vertical angles are congruent, okay? So step one would be AB is perpendicular to BE, that's given. Step two is angle ABC is a right angle. And that's just perpendicular lines intersect at right angles. It's really the definition of perpendicular, but remember when you're on Delta Math, it doesn't actually say definition of perpendicular, it actually gives the definition of perpendicular, which is perpendicular lines intersect at right angles. So that's what it's going to say on Delta Math. Perpendicular lines intersect at right angles. It's really just the definition of perpendicular. Then we have to do the same thing for the other right angle. We would have to say step 3, DE is perpendicular to AD. That's given. And step 4 is that angle is a right angle, angle EDC is a right angle. For the same reason as step 2. We'd say perpendicular lines intersect at right angles. Now, finally, after all that work, now we can say step 5, we can say angle ABC is congruent to angle EDC. And the reason for that is all right angles are congruent. We've established the fact that ABC is a right angle. We've established the fact that EDC is a right angle. So now ABC and EDC are congruent because all right angles are congruent. So that's kind of like the hardest part of the proof, is that first angle proving them congruent. Okay, I just want to remind you how that works. The rest of the proof is really straightforward. Step 6 is just the given line segments congruent. BC is congruent to DC. Given. So that's the pair of sides we were looking for. And then step 7 would be those vertical angles. Angle BCA is congruent to angle DCE. Angle BCA is congruent to angle DCE because vertical angles are congruent. And that's the second pair of angles in the angle side angle. Now I can say the triangles are congruent. Triangle BCA is congruent to triangle DCE by angle side angle. And the final step would be those two segments are congruent, AC and EC. AC is congruent to EC because I've shown that the triangles are congruent. Therefore, these sides are congruent because they're parts of those triangles. CP, CT, C. Corresponding parts of congruent triangles are congruent. Okay? Just bringing it all back. All the bad fever memories. Okay. So that's what tonight's homework is about. It's Unit 4 review, and it's just a couple proofs. There's also a couple problems on just not proving things, but using the congruence criteria to explain why you can prove triangles are congruent, okay, just based on a diagram. Any questions on that stuff? Okay, just a reminder, if there happens to be a snow day tomorrow, we're supposed to get a lot of snow tonight, but if there happens to be a snow day tomorrow, then the test will actually be on Monday and Tuesday instead of Friday and Monday. Okay, everything will just be pushed back a day. Any questions on that? Okay. So that's all I got for today.